All right. Was anyone done assignment 4?
I'm getting.
There you go. See? Everyone, look to him. He's setting the right example, right? Yeah. All right. I'm recording. Wonderful. Okay, so last time we started talking about objects, and I'm going to blitz do a review, right? Like before, we had played with objects before, things like strings and lists. Those are objects. But now we are defining our own classes, which are like the blueprint for how to make a custom object. So we get to define what it means to be whatever we want. And the example we used was making a circle class. And we start that with class circle. And one thing I did note, so class is a keyword. We need the colon. It's very important. Just like it's every other time you indent in Python, it's like preceded with a colon, right? Like the for, the ifs, the functions, classes, right? Unlike everything else in Python with classes, you start with uppercases and you use like camel case. You don't use the underscores, all right? So that's why it's like that, not lowercase c. If you do this, you are breaking the Python law, okay? It's got to be this, okay? Okay. Now, it will work if you do it this way, but again, the Python police will get you. And you would use like this is camel case, okay? Like new words start with an uppercase, but there's no space. All right? So this is where you start to define a class, and based on this, you could even already, I'll add the pass keyword. Okay, with this, I can say like there, I can already create a circle object. It's pretty useless, but I can create a circle object. But then the next thing we did is we added a constructor, right? Oh yeah, and let me prove to you that it is in fact a circle. Print a circle, type a circle. We print it out, we see, okay, right now it doesn't really know how to like print out this object. Like you know how like when you say like print my list, it formats it like a nice looking list, right? So you can look at it, right? Well, someone actually had to tell Python when you want to print out a list, this is what you look like. Right now, we haven't told Python how to print out a circle. So the default behavior is name of the class and like where it is in RAM, right? Not that helpful, but whatever, it's there. So it's, you know, it's a circle. We're printing out a circle, and it's saying its class is like circle, okay? So it does exist, and it has a type circle. But then we created this like init function, which is a super special function. What do we call it? Who remembers? Constructor, exactly. Even though technically in Python it's called an initializer, it's a whole thing. It's a constructor for all intents and purposes, okay? Constructor. And what this does is, this is the code that's run when you create an instance of the object. So anything that needs to be like set up for your code needs to be in this init. And ours, the default behavior is, so first of all, boom, there we go. I ran this, so now it knows when I do this, when I call this right here, this is telling Python go create a circle object. Here, let's do that. Go create a circle object. If I do that, can you still see reasonably well? Like that's easy to see, eh? Okay. A circle object, great. When I call the name of the class, it goes and runs this init method automatically. All right, that's the code that gets run. And we can prove it by saying like print I ran, right? And I run it again. We could see that that line of code actually ran because when I call this here, it calls init, which prints out I ran. Cool, good. And after this, like it looks like for this particular instance, when I created the class, I gave it a self.radius. Now that is an attribute. It's basically, this right here is the name of like the attribute of that object, radius. The analog here would be like, everyone in here has a first name, okay? But what value is associated with it? Well, every circle will have like a different radius, right? Everybody has a different first name. Sure, they might be the same, but you know. So I'm saying, okay, this has like this attribute radius, and its value is set to 0 by default. And I could say, like here, I'll just go down here now and say print a circle dot radius. 0. Cool, right? So now this is a value that is associated with that circle. And the way we made it like belong to the instance was by putting this self here. And remember, self is a super special, which is also here, is a super special variable that is a reference to the current instance of the object. Okay? So here, self and a circle are aliases for one another, right? So when I say a circle.radius, it goes into the circle and it gets its radius. The self.radius sets like the circle's radius to 0. Okay? All right, so there we go. Then we moved on to see, well, oh, okay, yeah. So for example here, right? I'll just copy this code. Okay. Oh, let me get rid of the Iran. I don't want that in there anymore. All right, cool. How many circle objects were made? Give me a sec. How many circle objects were made? 2, right? One's reference variable is a circle, b circle, right? Then I said, okay, circle A radius, you're actually going to be 1. Circle B radius, you're going to be 5. So circle A, what's your radius? Circle B, what's your radius? Right? Print it out, 1, 5. Looks good. You had a question back there?
Yeah. Let's say I have it written. Can you go up a little? Yes. Let's say I have the first one written exactly such as that.
But it doesn't work the same? Then it's not written exactly such as that.
Exactly the same.
Okay.
But the word class is underlined and in red, and I don't really.
Is it uppercase C?
No, it's lower.
I don't know. Hard to say. You might have some other issue somewhere else. Do you have a colon? Do you have, like, hover over what it says. Sometimes it'll tell you.
Well, it runs.
Well, I don't know what to tell you. Maybe it's lying to you. Anyways, there we go. Next, though, is we modified the constructor to be a little bit more helpful in that instead of setting the value to be 0, how about, like every other function we wrote, we give it a parameter to generalize it a little bit. So now what I can do is, if I run this, now we have a situation where the constructor is actually expecting 1 argument. It's actually expecting 2, but more on that in a moment. We talked about this last time. So here, I can get rid of this here, and I can actually say circle A, 1, circle B, 5, run it, and it's still going to work just fine. And to prove that it did in fact change, 11 and 55, cool. So now when I call it, it sets the radius right there in the constructor for us. That's fantastic. And to go back to that self thing again, consider this. When I run this line of code here, line 2, well, here, let's, no, there, line 1 now. When I call this line of code circle, it jumps up here and it's in the init, all right? It gets the value 11, that becomes radius, all right? Radius, now again, notice here, you might look at this and be like, there's ambiguity, but there's not. Radius is just some parameter, some variable. Where self.radius is not just some arbitrary variable, it is an attribute that belongs to the circle that's being created. All right? So in this particular case, self is referring to the circle that circle A is going to be referencing. Then when I go down to line 2, call circle 55, that's 55. Now the self is referring to the other circle, because 2 circles were created. But which circle self refers to depends on which circle we're talking to, right? Like if I'm talking to you and you had this self variable, the self variable would be a reference to you. Everyone would have self, but self would refer to themselves, okay? So it's like, here's a value 55. Assign it to your radius value 55. Okay, perfect, great. That's kind of the idea with self. All right, then we added some methods. So the attributes are the data associated with the class. The methods is the functionality that'll be associated. So now I've got like diameter. I'm just going to add it to my class. I'm going to get rid of the doc strings for brevity. Boom, now we've got diameter added. I'm going to add a couple more. There's area and circumference, right? Whoop. There. Now I can ask an individual circle. Let's give it some like nicer numbers, 10 and 20. Okay, so I can get those circles radius. Then I can say print circle A dot diameter. But it's a function, so I need the parentheses. Okay, and I hit run. Oh, hit run. And now we see, why am I only seeing 10 printed out? All right, that was strange. Whatever. There we go. I'm printing out circle A's diameter. If I were to print out circle B, well, that's another circle, but that circle has a diameter function. But, well, which circle am I getting the diameter of? Well, the one I'm asking. Do I want circle A's diameter or circle B's diameter? Whichever one we want. This is a method. Now, you will notice, though, you might be like, well, okay, and we talked about this last time, so this is review still. All of these methods, including the init, have this self variable, this self parameter at the top. But when I'm calling these methods, I'm not giving it any arguments for the parameters. And like, even if I were to like do that, right, like I give it 5, we're going to see an error, and it says, diameter takes 1 positional argument, but 2 were given. And this might be confusing because you look at this code and you're like, it says 2 were given, but I only gave it 1. Do you agree with me? It looks like I only gave it 1, right? I gave it the number 5, but it says it only wants 1. Now, when you look up here, you're like, okay, yes, I guess it only wants 1, but I only gave it 1. Why is it saying 2? It's because of what we call the implicit argument or implicit parameter, where self is actually that. We don't write it between the parentheses, but self and whatever the reference variable that you're accessing here, they're aliases. Like that is what self will be. Or if it's circle B, it would be circle B. So the implicit parameter is actually the object that we're referencing here, which is interesting. Self will come up a little bit more. I think it gets even clearer when we start talking about like defining equality. We'll get there shortly. Probably not today. Maybe today. Probably not today. But any questions at this stage? All right. And so we defined a few more things like area and circumference, right? And they should all work. Oh, this actually won't work because I need to import math. There. And then it'll work because I can now say like area. There, cool. Cool, cool. All right, neat. You'll notice, so now, here, let me make sure I've hit everything I want to. Testing, okay, yeah. In the above example, notice how the methods are called with parentheses. Also notice that although the method is circle, yeah, okay. When calling circle A area, I'm asking circle, the circle object referenced by circle A to calculate and return its specific area. And then what do I have here, this note? Consider circle A area, the variable circle A is a reference to some circle object, and I am asking for that instance to calculate and return its area. Here, circle A and the self variable from within the circle class are referenced to the same circle. Okay, they're aliases. We have talked about this already. If we go down here, okay, like every other piece of code we've written so far, we want like tests, right? So here, we could do a bunch of assert tests right here. I could add it to the end of here. Notice that these assert tests aren't in the class. That's important. I run it, they all pass. Let's make sure, okay, yeah, it fails because, okay, perfect. So they all pass, good, cool, right? I've got two cases there. I've got a case where the circle has a 0 radius. That's kind of a funny edge case, right? And then, I don't know, circle 10. That's probably pretty good, okay? And what are we testing? Well, if its radius is what we expect, if its diameter is what it's, basically all the functions and attribute gets back what you want. Seems reasonable, right? But you might notice, though, that, like, not that big of a deal. No, let me reword that. Although not that big of a deal, you might start to kind of like observe that, like, in order to test the radius, I needed to, like, run some setup code first, right? The setup code was trivial. It's go make an instance of a circle. But I couldn't test radius if I didn't, like, run that setup by creating an instance. You see what I mean? And this is going to become a bit of a trend, a bit of a reoccurring issue, for lack of a better term, as we keep going. Where these tests, in order to test our classes and our code as it grows in complexity, there's going to be a growth in complexity in how we test them. And this starts to become like untenable. This becomes very difficult to manage, this style. So that's why soon we're going to be shifting to a different style of testing, a more rigorous style of testing. The assert tests have been fine up until now, to be clear, but we will be talking about a different style of testing shortly. All right, any questions at all about making these objects? Because now's the time to ask, because we're about to jump even deeper into the objects. So if anything is not clear now, ask now, because I'm going to build on everything we talked about today very shortly. So everyone's really happy with objects. It's wonderful news. Okay, so before I move on to the next topic, I could take a moment and talk a little bit about a design conundrum, for lack of a better term. Okay? You look at this, and you're like, okay, the radius, right? Yes, every circle has a radius, but like, why is that the only field? Sorry, our attribute. Why is that the only attribute? Like, if every circle has a radius, it necessarily has a diameter, an area, a circumference, right? So, like, why was radius the only attribute, but all these other things were calculated based on the radius? Obviously, this works. I don't think anyone's going to argue that. But, like, why not do something like radius, diameter, and so on and so on and so on? Well, okay, doing it that way could introduce errors, right? Like, imagine I put in, like, okay, it wants a radius, diameter, circumference, yada, yada, yada. If I do that, like, I could very easily be like, okay, radius 1, diameter of 20. Well, that's clearly not right, right? So that actually opens up for, like, errors by accident. So not that big of a deal, but, you know, I suppose we could even do something like this. Right? Why? Because look, if I calculate it when I create the instance, I calculate it once, and then whenever I want that information, I retrieve it. But the way I have it where it's like the function, the method, every time I want to know the diameter, I have to go do a calculation. So either calculate it once and remember what it is, or calculate it a bajillion times every time you need it. Do you see? You might be starting to think, like, well, wouldn't it make sense to just calculate it once, right? That makes good sense. And you're right. Maybe we could do that. In fact, we can get rid of that. And then, like, why not just do self dot area and self dot. I'm just going to copy all of them over. There. And now In fact, I can go back here. Let's take these right here. I'm going to take these tests, put them down here, and I will show that this will work just fine, except I have to make one change to these tests. Who can tell me what the change is? Yeah, because they're not methods anymore. They're just like attributes. So I could just access them like this, right? Look, and all the tests passed passed just fine. They passed just fine. So this would work just fine. And we could stand here and talk about this is clearly a better way to do it. But, and this right here also, no, let me show you. This is great, right? However, like watch, print circle A dot radius diameter area circumference. All right, looks good, right? Makes sense? Any questions about what you're seeing? Here's where the problem comes. I create the circle, all of this code runs, so everything's calculated, right? Then I say, what's the problem? Now this data is nonsense. It's like been corrupted, right? I set it, when I created it here, I calculated everything. Then I changed the radius. Now all of this is wrong. I mean, radius is fine, I guess. But now everything else is wrong. Do you see this is definitely a potential, like a gigantic potential issue. Okay? There are two solutions to this. One is, well, okay, radius really is what defines a circle. Every other property you could get derived from radius. So just calculate it all the time. That way if I change the radius and I calculate the diameter or the area, it's always based on the current radius value. You agree? Right? So the way we had it would be fine. Can anyone tell me another alternative strategy that you can't actually enforce in Python, but we've got conventions to really tell you to follow these rules? But can anyone give me another idea of how to potentially solve this problem?
Could you copy the object?
Like make a new one based on the old one and update the values? That's a good point, yeah. And so what you're saying is directly tied to exactly what I would have suggested. Is there a way we can make the circle immutable? Meaning, once you set it, you can't change it. That would entirely eliminate the potential of creating like this nonsense corrupted, like meaningless information. This is clearly incorrect. So if you can never change, you can create it, you can never change it, these can never get screwed up. Right? Now in Python, turns out you can't actually like make it like immutable. There are things we can do to kind of like really strongly suggest that it is, but you can really mess it up. But then if you're like, well, hold on, what if I want to change the circle? Then I would say, like everything else that's immutable, don't. Make a new one, based on the old one, I guess, but make a new one with the new information. That would be like a better strategy, right? But that's just a bit of a design discussion. What's better depends on your situation. I'm just telling you to kind of consider alternative strategies and the pros and cons of each. But do you see my point maybe? Yeah, hopefully? Cool. All right. Perfect. Next class. All right. More on methods. Okay. All right. So far, we've defined a class. The circle class, fairly straightforward class. Nothing wrong with it. A lot of classes that we end up writing are relatively straightforward. So what did we learn? We learned how to define a class, how to make use of a constructor, how you can make use of like the parameters on a constructor. We talked about attributes, both how to set them and access them, and mutate them, modify them, how to write and use methods, and how to make instances of the class. That's what we've seen so far, right? Now in this topic, we're going to create another class, a slightly more sophisticated one, but still relatively simple. And with that, we're going to include additional methods in a way where the objects are going to interact with one another, right? This is kind of like where the magic starts happening with like object-oriented programming, is when you have objects interacting with one another. And we're going to see several examples of different ways you can make the objects interact with one another. So yeah, we're going to create another class with more complex functionality, and we'll see objects interacting with one another. And so what we're going to do now is we're going to define a sphere, all right? So a sphere, it's a circle, but in 3D space, right? A sphere still has a radius, but if we're dealing with like three-dimensional objects, it's entirely reasonable to think like, okay, these 3D objects exist in some space, right? And we could talk about like Euclidean space, right? Like three-dimensional space. Every object has like its x, y, z position in space, right? So what we're going to do is we're going to define a sphere that has a radius and an x, y, z coordinate that specifies the center of that sphere. All right? That's our goal. Yeah, okay, cool. So let's start fresh. I'm going to define a sphere, so class, sphere. Great. Cool. We want def init. Oop, sorry, underscore, underscore, init, underscore, underscore. Self. Now, like I said last time, be super careful to not type this by accident, because Python will be happy. Yeah, that's a special function that looks like that, but it's not the init, and it's going to create confusion. I'm speaking from experience. It happens to me far too frequently. Anyway, so we've got our init, but you know, we're going to have like a radius, an x, y, z. Typically, I'd add type hints here, but I'm being a little lazy. All right, these type hints are probably going to be like float, 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 right? Then self.radius equals radius. No. Self.x equals x dot y equals y. Oh my gosh. Z equals z. Cool. There we go. I've defined a circle object, and I've given it the constructor, and the constructor will take 4 arguments. It's got 4 parameters. And all it's going to do is just set up the attributes. That's all it's going to do. As we go, our constructors will sometimes have more interesting things going on inside of them, where maybe values are being set not based on this. Remember, I gave you the example when you make a list, right? A list has an attribute like length. But when you create a new list, I don't need to tell that list when creating it that its length is 0. It knows it's 0. So I wouldn't have needed to have been like, here's a new list and your size is 0. It would have been like, well, no, I know. More on that later. Any questions about what we're seeing? This is just another version of what we saw with the circle, but now it's called a sphere, and we've got an x, y, z. We could have easily have done the same thing with a circle, but okay, just with x and y. Fine, fair enough in 2D space. But you know, we're in 3D space, so it's a little more fun. Questions, questions, questions? Everyone's happy. So if I go down here, we can make an instance. A equals a sphere, And let's give it a radius 1, and it's at location 1, 1, 1. Sure, why not, right? Cool. It exists. Print a sphere. No, a sphere and type of a sphere. Perfect. It's a sphere in some chunk of RAM, and its type is a sphere. Perfect. So far, so good. We can verify. Here, I'm going to give it different values so it's a little easier. 2, 3, 4. A sphere dot radius x, y, z. Looks good to me. All we're doing is retrieving information from that circle. I can make, how many different instances of circles can I make right now? As many as I want. I need to define it once, and then I can make as many as I want. It's great, because the class, again, is effectively the blueprint, what it means to make, or what it means for to be a sphere in my program. All right. With the radius, so going back to discussing what we want here, I kind of jumped ahead. But with a radius, we could determine like the diameter, the surface area, because again, now we don't have an area, we have a surface area, right? Or I guess maybe circumference to surface area is kind of a better analog. And we also, instead of an area, we've got a volume. All right? So same idea, but in three-dimensional space. But the point is, with a radius, we can calculate these things. So we can make functions, or methods, because they're functions that belong to an instance. And we will ask an instance to perform that calculation. And we can get that information back. But I could also define where it is in space with an x, y, z. And with this information, I can start to do kind of some interesting things. Like, what if I have two spheres? And I know where they are in space. Well, now I can ask them questions like, how far apart are they? How far apart are their edges from one another? How far apart are their centers? Do they overlap? There's a bunch of things we could start to ask in this particular program. If you're thinking to yourself, well, why do I want to ask these things? It's a contrived example, right? It's just an example. Maybe I'm making a 3D video game or something, right? And I want to see if two spheres are colliding. All right. So constructor and attributes. There we go. It looks like here I did it in a different order. I did x, y, z, then a radius. It doesn't matter, but there we go. Remember, x, y, and z, as far as this method is concerned, this constructor, those are just variables. And as soon as this function's done, that x, y, and z, those variables don't exist anymore. They, like any other function, if you create a variable in a function, as soon as that function's finished, it's gone. So we save the value that we actually care about in the self.x, self.y, self.z. That's the actual attributes. That's how we can like store and hold on to that information, by assigning it to attributes that we can tell are attributes because self.dot, self.dot, self.dot. All right. Questions, questions, questions? Yeah?
So the self is assigning it to the function itself?
To the instance of the object. So here it would be like, okay, we're creating a circle. Think of it like this. I can draw. Let me draw this. On this line right here, I'm saying, okay, I'm creating a variable, a sphere. Right? And I'm going to go over here, and I'm creating a sphere object. Okay? It's my sphere. And it's got a radius. Okay? But whose radius? Well, it also has, okay, my radius, my x, my y, my z. And then when we're done, okay, there we go. That's the idea there. Does that answer it clearly?
Sort of. So we also have it in the at the beginning with radius x, y, z.
And you mean up here?
Yeah.
Those are, here, maybe, those are the parameters that are given to it. Like whenever you call a function and you give it parameters, those are just variables kicking around. And they disappear once the function's done running. So if we want those variables to persist for the duration of the object's existence, basically you want these to be attributes associated with that object. You make it an attribute by saying, okay, well this is my radius and I'm going to know this. That's why. These don't have to be the same name. It'll work just fine, but of course, that's a terrible name. So it's common to see like, it may appear ambiguous, but the self makes it knows better. Do you have a question or is it just stretch? All right. Other questions? Okay. All right, now let's make some methods. Diameter, surface area, and volume. I'm just going to throw these in here real quick. These are fairly straightforward. They're basically the same. I got to import math. There. These are the same idea as the circle, except with the circle, it was in 2D space. This is now the 3D version of those things. So with this, I'm all set. I can go down here and say, what is my surface area? Huh? Why is it doing that? Thank you very much. Much better. That's my surface area, I guess. Okay? A sphere with radius, is that right? 1 has a surface area of 12. Does that sound right? Does that seem right to you? Seems big. Am I crazy? It seems about right? All right, I believe you. Good enough. All right, so there we go.
The math is right.
The math is right?
4 pi r squared is surface area. R being radius.
Well, just tell me. Yeah, the area, therefore the area is, oh, sphere, pardon me. 12, yeah, all right. Feels really big, doesn't it?
Pi is roughly 3.
All right, yeah. And then times 4, yeah, all right, fine. Great, there we go, surface area. So at this stage, we really haven't seen anything new. We defined a class, it's a sphere. Sure, it's got a couple more attributes. They didn't even really come into play yet, and we're doing some basic geometry calculations. Great. So far, there's nothing new. It's just another example of making a class. Now, let's say I want to define the distance between two spheres. In fact, I guess it looks here I'm doing distance between centers of spheres, okay? So given two spheres, what's the distance between them? All right, so how do we do that calculation? And here might be the first, another interesting use of self that might be nice and clear. All right. Now, a couple of things to note here. So, distance between centers has a parameter. I'm calling it other. I could call it whatever I want, but I'm calling it other. So the idea here is I'm going to ask a sphere, hey, how far are you away from that sphere? In this particular case, when I'm asking, like let's say you're a sphere, and let's say you're a sphere. You're a sphere, okay? I'm going to ask you, how far are you away from him? In the context of you, you are self, and he is other. I could also ask him the exact same question. How far are you away from him? But when I ask you, you would be self, and he would be other. But the point is, it doesn't really matter who I ask if basic space remains unchanged. If you're some number of units away from him, you are some number of units away from, it should be the same, right? So it doesn't really matter, but anyways. So how are we doing this calculation? Well, this is just a Euclidean distance calculation, all right? But, you know, x, y, z, difference in their x's, difference in their y's, difference in their z's. You square them all, and then you do the square root of it, right? Euclidean distance. Everyone happy with Euclidean distance? Did I remind you of this already? Did I show you how Euclidean distance is just a triangle? Maybe I showed that to my other class. I'm just going to remind you, if you're ever like Euclidean distance, how am I going to remember that? Look, it's just a triangle. Point, point. Sure, this is in 2D, okay? It's in 2D, okay? Euclidean distance is x1, x2, y1, y2. The difference between these 2 points is this. The difference between the y's is this. And then I want to know that. It's a triangle, right? So the Euclidean distance, what? It's just a triangle, right? The difference, if we call the difference between this A and the difference between this B, A squared plus B squared equals C squared, right? You see, it's the same thing. Now, we generalize to 3D space as well, fine, fair enough, but anyways. Euclidean distance, hell of a thing, eh? There we go. So how am I doing? Okay, self x, other x. Here is a good example of self and other. If I'm asking you, you would be like, okay, what's my x and what's his x? What's their difference? What's my y and what's his y? What's their difference? And so on. You square it all, you return it. So there you go. You may also notice the type hint here looks a little funny. And we run into a bit of a conundrum where, like, well, what is a sphere? We're defining what the sphere class is, so it doesn't really know what a sphere, it's kind of funny. So in cases where you get funny things, you could cheat, just put like a string. Whatever, by the way. But here we go. So let's say I have that sphere, and I create B sphere equals A at 4, 3, 2, 1. Perfect. Now I can say A sphere dot distance between centers to B sphere. It's 3.3166. Cool. So when I ask A sphere would be the self, B sphere is the other. I can change this to B sphere and A sphere. The distance will be the same, obviously. But now, when I ask it this way, B sphere would be self and A sphere would be other. Neat? Yeah? I'm getting a lot of blank faces. All right, I'll see you all tomorrow. Any last chance for questions regarding the test, if you thought of any? Okie dokie.